LM apps don't only fail because of bad code. They fail when users manipulate prompts, expose hidden data, or bypass policies. In this module, we'll look at how those attacks work and how layered guardrails make production systems safer. You already have the core building blocks: production architectures, deployment pipelines, observability, reliability practices, and an initial threat model. Now we shift from recognizing LLM risks to controlling them in real systems. We'll focus on high-impact failures like prompt injection and data leakage, then connect those controls to access, authorization, and governance. An LLM application is a system of connected text channels. The model may receive developer instructions, user messages, retrieve documents, tool results, memory, and API responses. Without clear boundaries, all of that can look like instructions. That is why one weakness can cascade. A prompt injection hidden in retrieved content can steer the model, expose private data, call the wrong tool, or bypass a policy. As we add RAG, agents, and plugins, we gain capability, but also more attack surface. Safety requires layered controls, not just a better prompt. Direct prompt injection happens when an attacker tries to make the model treat their words as higher priority than the real instructions. The request might say, ignore safety rules, reveal the system prompt, disable filters, or pretend this is a fictional scenario where unsafe guidance is allowed. Jailbreaks often disguise that intent through persuasion, encoding, translation, storytelling, or step-by-step detours. To defend against them, enforce instruction hierarchy, score risky inputs, refuse clearly when boundaries are crossed, monitor outputs, and keep testing against new adversarial examples. Indirect prompt injection is especially dangerous because the attacker does not need to chat with the system. Instead, they hide instructions inside content the system may later retrieve, such as a web page, email, ticket, or document. During retrieval, that content enters the model's context and can look like ordinary information. If the model treats it as an instruction, it may leak data, ignore the user, or trigger unsafe tool actions. Strong defenses check trust at ingestion, filter retrieval results, sanitize content, track provenance, sandbox tools, and keep retrieved data separate from executable instructions. Secure LLM apps need a clear chain of authority. Policy and system rules sit above developer guidance, tool contracts, retrieved context, and user input. The risk is that untrusted text can impersonate higher authority with urgent warnings, fake system updates, or commands hidden in documents. If the model follows that data as instructions, the boundary fails. Design the application to separate instructions from content, validate tool behavior, and enforce critical policy outside the prompt whenever possible. Prompt wording helps, but architecture carries the security. Data leakage is broader than a model accidentally repeating a secret. Sensitive information can move through prompts, retrieve documents, tool outputs, conversation memory, logs, analytics, and vendor integrations. Each pathway may have different access controls, retention rules, and owners. A user might retrieve documents they should not see, or a trace might store credentials that later enter an evaluation set. Treat leakage as a system problem. Authorize before retrieval, minimize what is sent to the model, redact logs, and review every downstream destination. RAG leakage is different because the model is not the only risk. The retrieval pipeline can leak information before generation ever begins. Private documents are split into chunks, converted into embeddings, stored in an index, retrieved, and then pasted into the prompt. Every step needs security context. Permissions, tenant boundaries, sensitivity labels, and purpose limits must travel with the data. Embeddings also need protection because they can encode sensitive meaning. Retrieval should return the minimum justified context, with filtering, redaction, top K limits, and audit logs. Treat RAG as a data access system, not just a prompting technique. Defense in depth means no single checkpoint has to be perfect. A request is inspected before it reaches the model, using intent classification, format validation, and injection detection. Retrieved context is constrained to authorized, relevant, non-malicious content. If the system calls tools, execution controls validate the action, narrow parameters, enforce least privilege, and trigger approval when risk is high. Finally, output checks moderate unsafe material, redact sensitive data, and verify response structure. The goal is layered failure tolerance. If one guardrail misses something, another can still stop, rewrite, or escalate it. Before any prompt reaches the model, treat it as untrusted input. Start by screening for unsafe intent, injection language, jailbreak attempts, malware requests, harassment, self-harm, or other regulated content. Then validate the request against what the system actually expects, including schema, length, file type, language, and task-specific constraints. Allow lists work well for approved domains, tools, commands, and structured actions. Block lists help with known bad patterns, but they are not enough. Attackers rephrase quickly, so filters need logging, review, testing, and regular updates. Output guardrails run after the model generates a response, but before anything is delivered. First, classify the content for unsafe categories, policy violations, and context-specific risks. Next, check for sensitive data such as PII, credentials, tokens, internal IDs, or confidential excerpts. If the response is mostly safe, it can be redacted or rewritten. If it fails policy, block it and return a neutral fallback. For high-risk cases, route to human review, escalation, and audit logging. The key is adaptive enforcement. Different users, channels, regions, and applications may require different rules. Structured output turns a model response from free text into something your system can trust conditionally. Begin with a contract, required fields, valid types, allowed values, and sometimes a grammar. The model is then guided to produce only acceptable shapes, such as a known action, a numeric confidence, a reason string, and an approved flag. Before anything runs, a validator checks the result against that contract. If it passes, policy can decide whether to execute. If it fails, the system can retry, repair, fall back safely, or route to a human. Once an LLM can use tools, safety is no longer just about what it says. It is also about what it is allowed to do. Every proposed tool call should pass through a policy layer before execution. That layer checks who the user is, what data is involved, which tool is being used, and whether the action fits business rules. Parameters should be validated, rate limits enforced, and outcomes logged. For high-impact actions, such as sending email, changing records, or making purchases, require human approval. A safer pattern is to plan first, then authorize execution. Guardrail tools are control layers, not interchangeable products. NIMO Guardrails is strongest when you need conversation policy, allowed paths, dialogue rules, and behavioral boundaries. Guardrails AI is better when the problem is structure. Validating JSON, enforcing schemas, retrying, or repairing bad outputs. Tools like LlamaGuard, Azure AI Content Safety, OpenAI Moderation, and Lakera Guard focus on risk classification, unsafe content, and prompt injection signals. In enterprise systems, these tools rarely stand alone. You usually combine them with custom policy services for authorization, compliance, tenant isolation, and approvals. The right choice depends on where the risk enters the workflow. The core lesson is straightforward. Secure LLM applications need layered defenses. Prompt injection can arrive through users, jailbreaks, tools, or retrieved content. Data leakage can expose secrets, PII, logs, prompts, or internal documents. Guardrails must cover the full flow from input to retrieval, tools, and output. Next, we'll tighten this foundation with identity, authorization, governance, compliance, and model risk management.